Ions and ionic compounds. So atoms can readily lose or gain electrons. This can happen all the time. The electrons are not as bound as the nucleus particles are, like the protons and the neutrons. The protons and neutrons are kind of like glued together very, 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 and I mean it strongly. That's called the strong nuclear force versus the attractive force between the nucleus and the electron. It's actually much weaker. So they can actually be flung out. The electrons, like I said, can be lost or can be gained. If you look at the definition of an ion, it's a charged particle resulting from an atom gaining or losing electrons. So atoms now are no longer called atoms when they are charged. So we can either refer to them as cations, which is positively charged, or anions, which are negatively charged ions. It's important to remember this nomenclature because that's what we're going to refer to them. So here's a quick way, cats have paws, so it's, from cations and paws, so that's positive. Quick way of nice, interesting way. Look at it. So here's sodium. It has 11 protons. It has 11 electrons. You lose one of the electrons. Now you have one less electron than it used to have. So the overall charge is going to be positive. So just think about it. You had 11 protons plus 11. You lost one electron minus 10. So that's an overall of a positive 1. They do not equal. Of course, you can have more than plus 1. It could be plus 2. Now, with a negatively charged anion, imagine you have something like fluorine. So fluorine by itself has 9 protons and 9 electrons. And if it gains an electron, it becomes F minus because the number of protons did not change, but we actually have an extra electron. So you have one extra electron, hence the negative charge. Now, this negative and this positive, if it's 1, we usually don't show the number. But since we have a, we could, for some reason, show it in this case, we can just keep it like in sodium right here. So let's actually see how this would work out on the isotopic notation. Okay, so you have sodium with a positive 1 charge, and you're asked to calculate the number of electrons, protons, electrons, and neutrons. The number of protons is 11 down here. Now, you're used to just copying the number of electrons from the bottom because it's equal to that, but let's actually now investigate that number on the top. So I'm going to redraw this so I can have more freedom working with it here. And 11. Okay. The positive in this case, okay, it means it has the positive, it has 1 less electron. That's what a positive means. I know we're used to this. It's kind of counterintuitive for us. As humans, we think positive means a gain. Well, it's actually true. It's a gain of a positive charge, but the number of protons didn't change. What happens is you actually removed an electron. So therefore, there's 1 less electron. So in this case, since we have 11, we have 11 for protons, we're going to have 10 for the number of electrons. Now, of course, the number of neutrons stays the same. So you have 22 minus 11, which is also 11. Now, for selenium here, you have, let's do that. Protons, electrons, and neutrons. Now, so the number of protons is 34. But what does this minus 2 mean? Okay, what does that minus 2 mean? That minus 2 means it gained 2 electrons. So it's 2 more than this number. Once again, it may sound counterintuitive, but remember, what is the charge of the electron? It's negative. So that's why it's a minus 2. It tells us, this is giving us information that we have too many electrons. And they're not, again, the atom is not neutral anymore. So that minus 2 means you have 36 electrons. And of course, for the neutron, we take 79 minus 34. And we get 45 neutrons. So that's the idea behind ions. Just practice a few of these and you should be okay at that.